Welcome to this tutorial of chi-square test of independence. Chi-square test we do when we check the independence or the dependence between categorical variables. It's a non-parametric test. So let's have some common usage of chi-square test. So you do to check the statistical independence or association between two categorical variables. So if your categorical variables represent pre-test and post-test, means they are dependent sample. So in that condition, this test is not appropriate. So chi-square test you should do when your samples are not dependent, they are mutually exclusive. However, in such a situation when you have pre-test, post-test situation, you can do McNemar's test. So let's have a quick look at the data requirement for chi-square test. So data must meet the following requirements: 2 categorical variables, 2 or more categories with each group. For each group, you should have at least 2 or more categories. Other thing which is independence of observation, it means there is no relationship between the subjects in each group. For example, we can have a group like male and female. So these two groups will be mutually exclusive. We cannot have like same population pre and post. For example, you give some treatment and you test it before and after treatment. So same person you will be testing 2 times. You'll forming 2 groups in that way. So these 2 groups will not be considered for chi-square test. The categorical variables are not paired in any way. So of course, if they are paired, we should go for the McNemar's test. Another thing is relatively large sample size. So expected frequencies for each cell are at least 1, and expected frequencies should be at least 5 for the majority, say 80% of the cells. And how to form hypothesis in chi-square test? So the null hypothesis will form that variable is independent of variable 2, like variable A and B. We have 2 variables. We take some concrete example. For example, we want to test whether gender, male and female, and their choice for brands A, B, C, D. Is there any relationship between these 2 variables? So we can say that gender is independent of brand choice. And alternate hypothesis, you can have yes, gender is not independent of brand choice. So these two, these are ways you can frame your null and alternate hypothesis in chi-square test. So quickly have a look at the test, the formula. So I'll simplify this formula in when we solve the examples. Let's quickly have a look what things we require. So we require values of expected frequency and actual frequency. I take the just subtract actual from expected and take the square and divide this thing by expected, and we add all such values for all the cells and we get the chi-square statistics. For calculating the expected frequency, you need to calculate the row total, you need to calculate the column total, and you need to calculate the grand total, and you put in this. So for each cell you have to do this calculation. I'll give an example. So quickly let's do one example, one test by hand, and I'll do this calculation for you. So let's have a look at some data which we will have it here. Okay. So we have this data, and this has been done in this tutorial. I will do chi-square test for this data. In this data we have 3 brands and we have different age groups. So brands these are considered as categories, and this is one variable, brands, brand choice, and the age group from 15 to 25, 26 to 35, 36 to 45, 46 to 55. So these are the 4 categories of age. Now we will calculate the chi-square statistics based on the discussion we had. So let me write the formula for calculating the chi-square value. So chi-square value is calculated as follows. So first we calculate the expected frequency for each cell. For example, we have 6 cells. Okay, we have, say, these 6 cells. In these 6 cells, O is already given. The actual value is already given. We need to calculate the expected value. So for calculating the expected value, we need to calculate the row total of this. We write it here, and the column total. We also have the grand total, which is a total sample size, total frequency, sum of all the frequencies. So what we do, this is column total, this is row total. So we column total into row total and divide by total frequencies, whatever is the total count. So let's have that example, and let's try to solve that problem. So in this case, our row total is 212, column total is 225. So for this value, what is the expected frequency? So we can calculate expected frequency just multiplying 212 and 225 and then divide it by 703. So let me just do this calculation on calculator. Okay, and what we do, we just multiply 212 and 225, 225 into 212, and then divide this thing by 703. So we got the value as 67.85. 67.85. This value will plug in this that formula which we have just written. In this formula will plug in. So let me write it here. So actual frequency is 65, as we have seen in that cell. It is right there. This 65, and the value we have calculated is in this calculator 67.85. So let me write minus 67.85. Then I'll do the square it, and then I'll divide it this value by 67.85. And this calculation I'll do for each and every cell, and then I'll add all such values. So this is done already. I have done this. So let me just show you how it is done. It's been done. So first thing is the calculation for the expected value is done in this way, and then you calculate each of these expected value. So this value is 52.48. How it has been calculated? 164 into 225 divided by 703. How this value is calculated? 147 into 225 divided by 703. All these values, expected frequencies, has been calculated for each cell, and the value which O minus E squared and then divided by E has been calculated for each value. Then it is added. So now observed frequency, expected frequency, and we calculate based on this formula and add all these things. We get value 7.23. So this is the first step to calculate the chi-square statistics. So we got this value as the chi-square value. Now second thing is to calculate the degree of freedom. Degree of freedom we can calculate using the number of rows and number of columns. So we have 1, 2, 3 columns and 1, 2, 3, 4 rows. So the formula for calculating degree of freedom is number of rows minus 1 into number of columns minus 1. So we have 4 minus 1 and we have 3 minus 1. So we have 3 into 2, that is 6. So now we have two values. One value is we have 7.23, that is chi-square value. One value is the degree of freedom, that is 6. We already know the level of alpha that was given to us, 0.05. Now based on these values, we can calculate the corresponding p-value, whether it is significant or not. And then we can make a decision. These values are provided in the chi-square table. So we'll have a look at that table also, but it is already like the critical value for chi-square at the given significance level is 12.59. So anything below 12.59 will not be accepted. And as we know, we have discussed that our calculated value should be greater than the critical value. In our case, the calculated value is 7.23 and the critical value is 12.59, which is greater than the calculated value. So in this case, we cannot reject the null hypothesis. So when our null hypothesis cannot be rejected, we say there is no difference between the age group for these brands, or we say these two things, these two variables are independent of each other. They do not relate to each other.